We're Ready, Set, Grow. Today we're going to present our solution to world hunger. Over 795 million people in the world don't have enough food to eat. Food travels thousands of miles to feed them. This requires a lot of chemicals and GMOs. It is also very inefficient for the use of natural resources. Our solution is to combine robotics with aquaponics to form roboponics. Now we're going to explain the different parts of our system.
I'm Shreya. I created the water management system. The first variable I control is pH. Whoops. Maria just added a basin to the beaker. This makes the pH go up. pH is a hydrogen ion concentration. Luckily, this button runs a correction system that pumps an acid to make the pH go down. The plants like a pH between 5.5 and 7. While the fish like one from 6.5 to 7.5. So we have a set pH at 6.5. Usually this is measured using the water testing kit. However, I use an analog sensor, calibrated with check solutions, and peristaltic pumps to adjust the pH and to add medicine. My meters use RC Hobby servos that take a pulse with modulated signal and convert it into a reading. The nitrogen cycle is another big factor in our project. Fish produce waste, which turns into ammonia, then nitrites, and then nitrates, which are perfect for feeding the plants. Fish need safe water that have low amounts of all of these chemicals. This is usually measured with another kit. However, we use an I2C color sensor and a special enclosure to sense these chemicals.
I'm Nick. I worked on the timers and thermostats. We just started a 1-minute simulation. Plants need good water, but they also need pumps to water the grow beds, fans to strengthen the plants, and lights for photosynthesis. Timers were programmed with an I2C clock chip and relays that act as a computer-controlled switch to turn on the outlets. The sensor was a digital one-wire sensor. We needed a thermostat to control the water temperature. We programmed an on temperature, off temperature, and alarms for too high and too low. This is the low alarm.
Hi, I'm Maria, and I designed the monitoring and time-lapse photography system. There are many problems that you can't detect with the environmental and the water and chemistry system. I designed it so it can cover a large area. I used these relays to focus and to take pictures when needed. I just set my system to study the plants and fish. This is a healthy lettuce leaf. This is a healthy Mizuna plant. This plant is suffering from a disease called intervenal chondritis. It's an iron and potassium deficiency. We just send a signal over to the water and chemistry kit so it can pump the medicine. This is a healthy fish. This is another healthy fish. This fish is suffering from a disease called ick. We then again have to send the message so it can send in the blue medicine. We don't actually do image recognition, but the technology does exist to do this.
I'm Nora. I worked on the safety system. A complex system could fail. For example, a breathing apparatus, a nuclear system, and a self-driving car. We had several system failures as well. For example, when all the fish and plants died. Our solution is a simple game of Simon Says. I send a signal out to each one of the systems waiting for a response. This is called the heartbeat. If I don't get a response, I sound a warning message. I just killed Nick's environmental system. An alarm is sounding indicating that a system isn't working properly. I used opto-isolators and RJ45 cables to connect the system. Throughout this project, we learned about Arduinos, electronics, fish and plants, motors, sensors, and much more. We hope that one day our system will have an impact on the world.
Thanks for watching!
So how did you guys come up with the idea for this project?
Well, Nick came up with the idea to feed the world.
I originally thought pizza, but then thought plants would be a better option.
We went to the hydroponics store, and they gave us the idea for aquaponics.
Nora, what was your biggest challenge?
To get all the systems to communicate, we had to use opto-isolators and RJ45 cables.
Nick, what was your biggest challenge?
Since the hours were integers, programming the half hour, I needed to do hours plus minutes divided by 60 to a floating point variable.
Sure, what was your biggest challenge?
Calibrating a color sensor. It was really hard to get a color from just a bunch of numbers. We had to have an array of set values.
Maria, what was your biggest challenge?
My biggest challenge was getting my system to move with this tiny stepper motor. We then had to convert it to this bigger one, which is run by a gearbox.
Shreya, you talked about pulse width modulation. What is that?
It's a signal that turns on and off really fast. We can program the amount of time it turns on.
Hey, there were some plants here. What happened to all the plants?
We harvested them.
So you guys grew real plants?
Yeah, and real fish.
Wow. So what was the most significant thing you learned, Nora?
How to grow plants from germination to harvest.
And Nick, what was the most important thing you learned?
Practical applications of ratios. Ratio of water to fish and fish to plants.
And Maria, what was the most significant thing you learned?
Learning the math behind the time-lapse photography system.
And Shreya, what did you learn?
Even if you don't succeed at first, you have to try again.
So, one last question for you guys. What do you guys think about RoboFest?
We love RoboFest!
To learn more about our system, go to www.smartlabsrobotics.com. Make sure to click on the Ready, Set, Grow tab. We're adding lots of new videos.
When you press the key A.
Here's how my code works for the thermostats and timers. This is the Arduino IDE. The slashes mean a comment, so I put notes in to remember what I did and for anyone else to understand it. Includes are ways to bring in other code. You want to specify what you want, and it is all based on the examples. Let me show you how the examples work. For example, if we want to see a Pololu A-Star music example, we click on File, Examples, then scroll down to A-Star, and then pick Buzzer Basics. Here's the code to play a custom song. I'll show you a similar code in my program. The examples make it very easy. We need the includes for the one-wire sensor and for the I2C clock. Interesting, the one-wire system needs 3 wires and the 2-wire system uses 4. That's because you need power and ground. Here are the addresses for the sensors. Here are the includes for the Pololu libraries. The LCD buzzer are easy to define. For the alarms, we use a series of notes, just like the example code I showed you. These variables are used for the thermostats to determine when to turn the heater on and when to play the alarms. We define all the pins that we use. Here are the variables to read the clock. To make it easy to set the timers to partial hours, we need to create these floating point variables for decimal hours and minutes. The setup runs only once and is used to set up all our variables, start the sensors and clocks. Lots of this just came from the sample code provided with the library. Nora helped me set up the variables to talk to our safety system. Here is the loop. It just keeps running over and over. After the heartbeat check, we check for pressing the demo button. Next, we read the temperature sensors and display them on the LCD. Here we read the real-time clock and do the calculations for the decimal hours and minutes. Remember what I was saying. This makes it easy to use partial hours, like 9:30 would be 9.5 in decimal hours. For the demo, we shut everything off after the 60-second demo. Digital write is an output. Now we set the relay states. Note that low turns the relay on and high turns it off. For the light, we want it on before and after the demo, so the logic is a little different here. Here is the thermostat logic to set the relay based on a defined